Hello, welcome to my classroom. Let me apologize for delay in recording and uploading my lectures regularly. In fact, it was due to some pressing circumstances on my part, but now I'll try to be regular in recording my further lectures. Well, today's topic for discussion is diurnal variations in soil temperature. All of you are aware that the air temperature it shows diurnal fluctuations. In fact, we have the temperatures are lower during the morning hours, and then temperatures they start rising after around 1 p.m. or between 1 and 2 p.m. It attains peak, then again temperatures start decreasing, and then this cycle moves on for the next day and so on. Similarly, the soil temperature also shows variations. In fact, these meteorological, regimes, these are characterized by the variations during day and night, as well as during summers and winters, what you call as seasonal variations. And similarly, the soil temperature also shows some variations with time and time over the day as well as time during the season. And first of all, now just having a look at the diurnal cycle, you can see the temperatures are minimum during the morning hours, then temperature starts rising, then after attaining the peak, what we call as maxima amplitude, in the temperature starts decreasing. If this dotted line shows the temperature at soil temperature at the surface, then if you see at 10 centimeter, the temperature during the morning hours is higher, it starts again increasing, and then peak is maximum, maxima amplitude is reached, again temperature starts decreasing. Then at 30 centimeter, you can again see the temperature it rising very slowly as compared to 10 centimeter or as compared to 5 centimeter at the surface. Then it again achieves a peak and then again starts decreasing. So we have a minimum amplitude and maxima amplitude. So maxima amplitude is reached at the surface earlier than at the subsurface layers. So see over here, this is maxima amplitude, but at 10 centimeter, the maxima amplitude or peak soil temperature is delayed by some hours, and similarly as you go at 30 centimeter depth, the delays is there. So number one. Number two, the increase in temperature at the soil surface as well as the rate of decrease of temperature, these are higher at the surface, say 5 centimeter, as compared to subsurface layers, maybe 10 centimeter, maybe 30 centimeters. This is how the things go. So you already know this. This is what happens to the air temperature. This is what happening to the soil temperature. But of course, there is the trend. It varies with soil depth. Now this is all what you say about the diurnal variations. But here in this case, I'll be explaining you the diurnal trends of air and soil temperature. In this is actual, a study carried out at Punjab Agriculture University by one of our master's students, and this is a very classical study where we actually try to explain the diurnal variations in soil temperature at different depths. This is very interesting. Now this A figure A, this is June 5 to 6, June 5th and 6th cycle, and June is considered to be the hottest period on this part of the globe. The average temperatures remaining above 40 degrees centigrade, whereas B figure, this is for the July 2 and 3. In fact, from 1st July onwards, we start expecting the rains, the weather becomes more humid, temperatures come down. So you can see over here the dotted line, the temperature over here, the peak temperature is near about 40 degrees centigrade, and here it is around 35, 36 degrees centigrade. Now if you see the solar radiation on June 5th, it is 633 Langley as compared to 603 Langley during July 2nd to 3rd. Now this is clear sunny day, this is also clear sunny day, and we have the depths 5 centimeter, 10 centimeter, 15 centimeter, 30, 50, 100, 200 centimeter soil depths where the temperature was recorded. Now you can see that during the morning hours, if morning I should say, at 8 hours, 008 hours, and this 8 hours means 2.5 hours after the sunrise. Now this is the situation at 8 hours, and sunrise was around 5:30 in the morning, 05:30 hours, and the temperature it was minimum at the surface. This is very interesting. This is the surface layer at 5 centimeter. At 10 centimeter, this hollow triangle, the temperature is higher. At 15 centimeter, this dot still higher. Then at 30 centimeter, you can see it is still higher, and almost similar at 50 centimeter depth. So that means the temperature is minimum at the surface layer because heat is moving out of soil. It is going out of soil, so the lower layers they have higher temperature. But if you go to after 50, 100 centimeter, the temperature is it immediately comes down at 200 centimeter soil depth. The temperature is minimum. Then, as now the effect of solar radiation, as the solar flux it increases, with the increase in solar flux the temperature also starts increasing. We know the air temperature is also increasing. This is a line for air temperature. This is for temperature at 5 centimeter, at 10 centimeter, then at 30, 50, 100 and so on. Now it attains maxima. The soil temperature was as I said 5 centimeter. It is around 47 point something. Yes, if I see my papers, at 5 centimeter it was 45.7 degrees centigrade, and it reached at 15:30 hours, whereas the peak flux of solar radiation, this is here peak flux of solar radiation, it was 3.5 hours before that. So solar this maxima amplitude or peak soil temperature at 5 centimeter depth, it was delayed by 3.5 hours after the peak flux of solar radiation. So that means the heat started penetrating, it warmed up the soil at 5 centimeter, then still penetrated down, because it is warming up all the layers. The temperature of 10 centimeter is increasing, 15 centimeter is increasing, 30 centimeter is increasing, but you can see there is no increase in soil temperature at 50 centimeter depth. This shows that the soil temperature, or in fact I should say the heat wave, it damped off. Heat wave disappeared after 30 centimeters. So we also call this as damping of depth. That means the soil depth where we do not observe any diurnal variation in soil temperature. Number one. Number two, if this peak appeared after 3.5 hours after the peak of solar flux, this peak at 10 centimeter, it was further delayed, and at 15 further delayed, at 30 you can see further delayed. So as soil depth increases, this peak maxima or maxima amplitude or peak soil temperature, this gets shifted or this gets delayed. And if we see, as I said, that at 5 centimeter the peak soil temperature was 45.7 degrees centigrade, at 10 centimeter it was 43.4 degrees centigrade, at 15 degree it was 41.6, at 30 centimeter it was 37.8. Yes, the peak temperature at the soil surface was maximum, decreased at 10 centimeter, further decreased at 15, further decreased at 30 centimeter. So as you move down, the peak temperature decreased. So in lower layers, the soil temperature is quite lower than that of air temperature, or even than of the surface soil temperature. And also the time lag. This is the time lag. So time lag, as I said, in the 5 centimeter soil layer, it was 3.5 hours. That means it is difference in the peak time of the solar radiation and peak time of the soil temperature at 5 centimeter. It was 3.5. So this time lag, it increased with soil depth. Okay, so these are some points. After attaining now the maximum temperature, as the solar radiation then starts decreasing, as you know, the sun, during the afternoon hours, similarly the soil temperature also starts decreasing. So temperature at 5 centimeter is decreasing, even at 10 centimeter, 30 centimeter, but at 50 centimeter it is more or less straight line. Then even at 100 centimeter there is no diurnal fluctuation, and of course at 200 centimeter there is no diurnal fluctuation. So second thing which you could observe over here is that as the temperature decreases, the rate of decrease of soil temperature, as I said in the first slide, the rate of decrease of soil temperature is faster at the surface layer, then this rate decreases with soil depth. And after attaining, as I said, the maximum temperature, the soil temperature at various depths, it also starts decreasing because soil starts cooling. Soil layers, they respond cooling in response to declining solar radiation. And the rate of cooling, as I said, it was maximum in the surface layer, and at 5 centimeter the minimum temperature was 31.2 over here. At 10 centimeter it was 32.6. At 15 centimeter it was 33.2. So as I said that the temperature at the surface was minimum during the morning hours, same was true during the evening hours. So this decrease in temperature at 30 centimeter, it was still decreasing till 9 hours, whereas in case of 5, 10 and 15 centimeter soil layers, this minimum temperature was attained between 6 and 7 hours. But in case of 30 centimeter, it was still decreasing. That means till 9 p.m. or 9 hours in the morning. So this is how the soil temperature varies. Now diurnal fluctuations in soil temperature, that means the difference between the peak temperature, maximum temperature and minimum temperature at different soil layers, it was 14.5 degrees centigrade at 5 centimeter, then it decreased to 10.8 at 10 centimeter, 8.4 at 15 centimeter and 3 degrees centigrade at 30 centimeter. So that means as you go deeper, the difference between or diurnal fluctuation, it decreases, or in other words, the difference between peak temperature and minimum temperature, it decreases with depth, and ultimately at 50 centimeter, 50 centimeter, there was no I should say diurnal fluctuation. Similarly at 100 centimeter and similarly at 100 centimeter. This shows that here I will explain one practical example. What we observe in our this part of the country or this part of the globe, that is northwest Punjab, or you can say in South Asia, because we are part of Indo-Gangetic plains in South Asia. So here what we observe that when we extract groundwater during the winter hours, so it is bit warmer, but on the other hand it seems to be warmer, but on the other hand during summer hours the ground water, it seems to be colder. In fact, neither it is warm nor gets warmed or cold. There is no seasonal fluctuation. Similarly, you can observe this thing during the night hours and day hours also. During day hours, here if you extract the groundwater, you could see that this seems to be a bit cooler, but during here it seems to be a bit warmer, but actually it is not. It is only because there is no fluctuation beyond 50 centimeter depth, and yes, of course we extract the water from the deeper layers which do not observe any diurnal variations. The temperature throughout the day, it remains similar. So when it is the hottest part of the day, the water seems to be colder. When it is coldest part of the day, the water seems to be a bit warmer. So this is the situation on June 5th and 6th. on July 2nd and 3rd, what happened that in between there was, it's of course it's a bare plot, as I said, both are bare plots. So in between, what happened that after this June 5th and 6th, there was a sort of incidental irrigation of 8 centimeter on the same plot. It was on June 7th. And then after between June 21st and July 1, there was 8 centimeter of rain. So that means 15 centimeter in between this period, that June 5 to 6 and July 2nd to 3rd, there was 8 plus 8, you can say 16 centimeter of water which entered into the soil. Then you can see what happened over here. Of course, because as I said, the temperatures come down here, air temperature also decreases. But similar, the trend of, the diurnal variation trend was almost similar as on June 2nd. The only thing is that soil total on the whole, the diurnal trends, as I said, were similar to those of June 5th and 6th. Soil temperature at different depths in at least 50 centimeter zone, it was generally lower by 4 to 6 degrees centigrade as compared to those of June 5th and 6th. Whereas at 200 centimeter, the soil temperature was higher by 1.4 degrees centigrade. So this is the only difference between, because, and this difference is of course because of the rain, because of the incidental irrigation, and what also the diurnal variation temperature fluctuations also decreased. At 500 centimeter, it was 12.1 degrees centigrade. At 10 centimeter, it was 9.9 degrees centigrade. At 15 centimeter, it decreased to 7.3 degrees centigrade. At 30 centimeter, it decreased to 3.6 degrees centigrade. So the trend is similar. Same thing happened on June 5th and 6th. The only difference is that amplitude of the values, it was decreased. And air temperature attained its maximum value at 1500 hours. On June 5th, the air temperature attained maximum value on 12:45. So yes, air temperature peak, it was delayed on June 2nd. It was because of the weather conditions. As I said, the temperature becomes more, the atmosphere becomes more humid, the temperatures become lower, and air temperature minima, it reached at 20 to 30 hours and persisted till this is minima almost, we should say, persisted till 006 hours during the morning. So now the soil is not bare, it is now maize crop without any mulch cover. Now you see what happens to the soil temperature when there is crop, and how it is different from that of the bare soil. Now here the effect you can see here on June 5th and 6th, it is sparse cover, because the maize crop has not fully covered the soil surface, so vegetation cover is sparse. But here on July 2nd and 3rd, it is almost fully covered and well developed crop. Temperature patterns, they are similar to bare soil, as I said, during morning hours, higher at the surface, then lower at the surface, then increasing with soil depth. But here what you can observe, that almost the peak temperature of air and 5 centimeter soil depth mostly similar. But if you remember that in previous case, the soil temperature of 5 centimeter, it was quite higher than that of air temperature. Air temperature is almost 38 point something as compared to 43.7 degrees centigrade at 5 degrees centigrade. But here these two peaks are almost similar, slightly higher at 5 centimeter, but the difference is less. It could be because of the crop canopy, because crop canopy, it gives it lowers the soil temperature, it intercepts the the heat. Now here we have recorded temperatures at 5, 10, 20, 50, 100 centimeter, and trend is same, yes. And the difference then, soil temperature at 50 centimeter, if we see, yes, it is a no diurnal fluctuation. Again at 100 centimeter, no diurnal fluctuations. So air temperature on June 5th, it remained below 5 centimeter temperature, 5 centimeter depth, but the difference was very small. And if you compare it on the July 2nd and 3rd, because again here it was incidental irrigation, as I said, plus it was, rainfall was there. And because of this, you can see, and also the effect of crop cover, you can see that this is the combined effect of soil moisture as well as crop cover, that even the temperature at 5 degrees centigrade is very less than and that of the air temperature. And this is how the crop cover affects soil temperature, very important. And here the diurnal fluctuations in air temperature are 11 degrees centigrade on July 2 and 3, the average diurnal fluctuations. But on July 5th and 6th, the diurnal fluctuation is higher, 17 degrees centigrade. So not only the magnitude of temperature, it decreases with due to the effect of mulching as well as the effect of this soil moisture. So yes, both are cropped fields, unmulched crop fields, but still the diurnal fluctuation in case on July 5th and 6th, that is 17 degrees centigrade, and this diurnal fluctuation decreased to 11 degrees centigrade on July, and this is the only because of effect of soil moisture. Here we had rainfall and irrigation, so that lowered the soil temperature. Now what happens when you have a crop cover as well as mulch? So this is very interesting. See over here the peak of 40 degrees centigrade air temperature, and the peak is slightly some 32 something point, in case of 5 centimeter soil depth, which is covered with straw mulch. And you can see the straw mulch, the temperature diurnal fluctuation is just 4.3 degrees centigrade at 5 centimeter, decreased to 3 degrees centigrade at 10 centimeter, and further decreased to 2.1 degrees centigrade at 20 centimeter. So that means the diurnal fluctuations in case of with mulching, they drastically reduced. So I should say these are minimum. And when you have unmulched, if you remember, in case of unmulched, it was 13.8 degrees centigrade diurnal fluctuation at the 5 centimeter, decreased to 8.6 degrees centigrade at 10 centimeter, and 6 degrees centigrade at 20 centimeter depth. But then these values then decreased to I should say 4.3 degrees centigrade. Yes, in this case this decreased to 4.3 degrees centigrade as compared to 13.8 in unmulched, 3 degrees centigrade at 10 centimeter in comparison to 8.6 degrees centigrade in unmulched, and at 20 centimeter it was just 2.1 degrees centigrade in with straw mulching. And if you see on July 2 and 3, again now it is, yes, crop cover plus mulching plus increased soil moisture because of incidental irrigation as well as the rains. And what happened over here, now this difference between the the difference which was earlier 9.5 degrees centigrade, this difference considerably reduced to 2.7 degrees centigrade between maximum and minimum temperatures. And at 5 centimeter, the difference being 9.5 on June 5th and 6th, 9.5 degrees centigrade. This decreased to 2.7 degrees centigrade on July 2nd and 3rd cycle. At 5 centimeter, at 10 centimeter it was 1.9 degrees centigrade, at 20 centimeter it was just 0.4 degrees centimeter. You can say at 20 centimeter, almost no diurnal fluctuation, I should say. So this is how the mulching, combined effect of mulching and crop cover and of course soil moisture, how it lowers the soil temperature. So if you see the seasonal trends in soil temperature at 4 depths, yes, 5, 10, 15, 20 degrees centigrade, yes, of course the temperature at the 5 centimeter is highest, followed by 10 centimeter, 15 centimeter, and 20 centimeter. From June, if you have, here we had irrigation, the temperatures of all the layers, they fell down, trend being similar, then again increasing. Then here it was rain, 25.7 millimeter, temperatures again fell down, again started increasing. Then we had rain, two events of rains, and again temperature, there was sharp fall in temperature, again rising. So this is how, because of the effect of moisture, even the seasonal trends in seasonal temperature also shows quite variation. And seasonal trends of air and maximum temperature at three depths. This is air temperature. This is this dotted lines are 5 centimeter, 10 centimeter, 15 centimeter, that's bare soil, and the solid lines 5 centimeter, 10 centimeter, 15 centimeter, this is covered with wheat straw. And you can see 5 centimeter bare soil, 5 centimeter wheat straw, how it lowers the temperature over the time in all the cases, except when you had rains. The differences between mulched and unmulched soil temperatures, that differences, they narrow down quietly. And then again, as the soil becomes dry, so the differences become conspicuous. So at all the depths, the surface, straw mulch, it helped in decreasing the temperatures. So this is all about the diurnal variations and seasonal variations in soil temperature, which I tried to explain by giving you a practical example by an actual study being carried out in northwestern Indo-Gangetic plains. Thank you very much.